Hi, it's Miss Skelton here. Today we're going to be talking about factoring with the greatest common factor. So welcome to week 2 of remote learning. The goal this week is that you're going to watch a couple of videos, and then there'll be at least 1 or 2 ways that you practice and submit your work, and we kind of go from there. So let's jump right in, and then when we finish the notes, I'll kind of break down the assignments for this week. Okay, so the first important thing is that we know what a greatest common factor is. You probably, or I know you did, talk about it back in even elementary school. You probably called it the GCF. And it's just the biggest number that can divide evenly into a set of numbers. So the next few weeks we're going to be working on factoring. And factoring is when we divide polynomials. So last week you got to practice multiplying. The week before spring break we got to add and subtract them. Factoring is how we describe dividing polynomials. So our goal is to use the GCF. So question, how can I use the GCF, the greatest common factor, to factor? And what we're really going to be doing today is undistributing, distributing backwards, basically. Okay, so if you can't print these notes out, it's totally fine. You can write examples down on paper. It doesn't have to be on a printout. It can just be on notebook paper. You're not turning your notes in. Okay, so it says the greatest common factor is the largest term, hence the greatest, that divides evenly into a set of terms. So we want to look at the biggest number that divides evenly into 8 and 12. Our goal is to find the greatest common factor. So you want to think of numbers that 8 and 12 can both be divided by. Maybe back in elementary school, your teacher, if you were like me, my teacher made me list out all the numbers that can go into 8. Like 1 and 8, 2 and 4. But if you try to divide it by 3 or by 5 or 6, that doesn't work. So 8 is divisible by 1, 2, 4, and 8. 12, well, that would be 1 times 12, or, let's see, 2 goes into 12, 2 and 6. And then if I keep going, 3 goes into 12, 3 times 4. And if you list out all the factors, then you'd want to find the biggest one that they have in common. Okay, our goal is that we don't have to list all the factors out each time, because that would take a really long time. So when you look at these, hopefully you'd say, okay, 2 goes into both, but actually 4 goes into both, and that's bigger. Okay, let's try the next one. Of course, it's algebra, so we can't stick with only letters forever. We have to throw variables in there. This is x to the 5th. For this first one, I'm going to kind of write it out the same way I did the last one. So think about x to the 5th. Well, if I expand that out, it's x times x times x times x times x. 5x is multiplying. And x cubed, x times x times x, 3x is multiplying. And if I look at what they have in common, how many x's do they share? Well, they both have 3 x's at least multiplying. So their GCF is x times x, or x cubed. So even though we're finding the greatest common factor, it ended up being, the one with the smaller exponent. Okay, let's put the numbers and variables together. So let's find the GCF of 16m squared and 20m cubed. So let's look at the numbers first. Biggest numbers that go into 16 and 20. Well, I know 2 does. They're both even. But how about bigger than 2? Not 3. Okay, 4 goes into both. If you try to think about bigger numbers than that, 20 can be divided by 10, but 16 can't. Or 16 can be divided by 8, but 20 can't. So I think our greatest common factor is going to be 4, and then with m's. So this one has m squared. I'm going to expand it just to remind you. That's m times m. M cubed, m times m times m. And if I look at how many they share, well, they each have 2 m's, the smaller of the exponents again. So their GCF is 4m squared. Okay, let's try 56 and 32. Let's see, the greatest number that goes into 56 and 32. Well, if you ever get stuck, I'm going to show you that there is a little shortcut or a way that the calculator can help you. So if you have a graphing calculator, or if you downloaded one of the free apps, Calculate 84 or Wabbit Emu, they're both online. I put the directions on downloading both of them on Canvas last week. So in your calculator, if you go to Math, hit the right arrow to Number, and then if you scroll down to option 9, it says GCD instead of GCF. And then if you type the numbers you're trying to find, 56, and then there's a comma right above the 7, and you put 32, and then hit enter, it'll tell me the greatest thing that can go into both is 8. So again, that's Math, right arrow, and number 9, GCD. And it told us the GCF, it can only do the numbers, it can't do the letters. Also, if you just feel confident in your math multiplication tables, you're not going to need to use this, but it's always a nice thing to have. You can only try 2 numbers at a time, and you don't want to put any negatives or anything like that in there. Okay, then if I look at their C's, I have 2 here, 1 here. Okay, so they only share 1 because this one only has 1. It doesn't have 2 like the 56c squared. Okay, so what we're going to do now is actually use this to factor. So back at the beginning of the year, we started distributing, and then last week your assignment looked like this, where you had to take a monomial, a single term, and multiply it into a polynomial. So 4x times x, 4x squared. Okay, 4x times 5, positive 20x. Well, today we're going to do that backwards. Our problems are going to start looking like 4x squared plus 20x. We are going to find the greatest common factor between them and divide it out of the problem. So the answers will look like this here. Okay, I promise it's not that scary. Let's try it. So factor, it's the opposite of multiplication. We want to factor 4x squared minus 3x. Let's find what they have in common. 4 and 3. What can they be divided by? Nothing other than 1. So I'll just say 1. And then look at their x's. The first one has 2x squared. And the second one just has 1x. So they each have at least 1x. So when we do this backwards, when we factor, we're going to bring the GCF to the front. And in the parentheses, we're going to write what is left behind when we divide the 1x out. So this is really the math that we're doing. We are dividing both of these by 1x. So 4 divided by 1, which is a little 4 here. X squared, if I divided by an x, remember that's going to take away one of the exponents. There were 2 x's, we took 1 out, so the exponent's going to decrease by 1. 3 divided by 1, or negative 3 divided by 1 would be negative 3. And then here, if I have x divided by x and they both are just x to the first, they're going to cancel each other out. This expression that we got here is actually our answer. Okay, now I know it seems a little weird, but we just undistributed or distributed backwards. If you wanted to check your answer, which I'm not requiring you to do, you could multiply it. So if I did 1x times 4x, oh, that would be 4x squared. If I did 1x times negative 3, that would be negative 3x. And that gives me back the problem I started with. So you can be 100% confident of your answer every time. Okay, let's practice more. So I have another binomial. Let's see what they share. 24x squared and 6x. Let's see, 6. Does 6 go into both? It looks like it does. And then if I look, this one has x squared. This only has x. So I can only take an x out of each one. So I'll have 6x that I'm going to divide out of the problem. It's the greatest common factor. Okay, so 24 divided by 6 is 4. I had 2 x's. I took 1 out, so there's still 1 left. These two, if I multiply them together, would give me the 24x squared that I started with. 6 divided by 6, positive 1. And when my x's are the same, x divided by x, they cancel each other out. My final answer has the GCF in front. And what I was left with afterwards in parentheses. I again could double check that it multiplies and makes the original problem back again. All right, let's keep going. GCF, I have 12a cubed and 16a squared. 12 and 16. Let's look at those front numbers. They could both be divided by 2, but let's try bigger than 2. How about 4? Okay, good. I have a cubed and a squared. They each have at least 2 a's. So another trick is look at the smallest exponent, and that will always be in your GCF. So like I could even look ahead to the next one. The smallest exponent's just 1y, that'll be in my GCF. I could look at number 10. The smallest exponent has x squared, that's going to be in my GCF. Okay, so let's finish this problem though. So 4a squared. And now we're going to divide by 4 and divide by a squared. So basically take 2 of the a's away. 12 divided by 4, 3. A cubed, if I take 2 of those a's out, remember the exponent subtract, it'll just leave me with 1a there. Or 3a, exponent 1. Negative 16 divided by 4 is negative 4. And my a squareds, oh, they're the same. They cancel out. Final answer. You should double at the end, look in your parentheses, and make sure they don't still have anything in common. 3 and 4, neither of them share an A. That's good. You don't want there to still be anything in common in the parentheses, otherwise you didn't find the greatest common factor at the beginning. So we're doing good. Let's keep going. Oh man, we have a trinomial. That's okay. We're going to apply the same process. The only thing we can't do is type all 3 in the calculator at once. So we'll just have to think about what goes into 10, 20, and 5. Okay, the smallest one, 5, that actually goes into all 3. And we said a minute ago, the smallest exponent is y. They each have at least 1y. I'm bring the 5y to the front. And I'm just going to have a trinomial left in my parentheses. So we're going to divide by 5 and take away a y. If you don't want to write that step, you don't have to. I want you to get to the point where you don't need to, but it's okay if you need to right now. So 10 divided by 5 is 2. There were 3 y's, but I'm taking 1 out. So now there are 2. 20 divided by 5, so positive 4. There were 2 y's in y squared. I divided 1 out. There's still 1 left. Negative 5 divided by 5 is negative 1. There was a y. We divided that y out, which cancels, and I have my final answer. Okay, if we were in class right now, I would have us all pause and have you try the next few and work ahead. And if you're in my A-Day class, we actually did this lesson the Friday before the break, and that's exactly what we did. So I would pause and try it, and then come back and see if you're right. I'm going to keep working through them, though. So next one, 16, 8, and 4. Let's see, I'll check and see. Can 4 go into all of them? Yep, looks like it. The smallest exponent's just an x. So I'm going to take a 4x out, divide them all by 4, take away an x, and see what I get. 16 divided by 4 is 4. There were 3, I took 1 out, so now it's just squared. Negative 8 divided by 4 is negative 2. There were 2 x's, I took 1 out, 1 left. Negative 4 divided by 4 is negative 1. There was an x, but I divided it out. So it cancels, and here's my final answer. All right, let's look at the next one. 6, 4, and 2. All right, they're all even. It looks like 2 goes into all of them. And then I have a 4th power, cubed, and squared. They each have at least 2 x's. And I know some of you might say, is it always going to be the one at the end? Is that always going to be my GCF? No, it's not. Think back to the very first one. That wasn't true there. It wasn't true on number 7. But it is true on these last few that we did. Okay, let's divide by 2x squared. And see what we get. 6 divided by 2 is 3. I had 4 x's, I took 2 out, so it leaves an x squared. 4 divided by 2, I have a 2. There were 3 x's, I took 2 out, and I have 1 left. And negative 2 divided by 2 is negative 1. And then my x squareds cancel. So there's my final answer. All right, 2 left, guys. Hang in there with me. So 11 says 12x squared y minus 8xy squared. Okay, even though it's multiple letters, it's okay. We're not scared. We can do it. 12 and 8. What goes into both of those? Not 8. Has to be smaller. How about 4? Both can be divided by 4. Now I want us to look letter by letter. So look only at the x's. This one has 2. This one only has 1. So I can just say that they have 1 in common. In the y's, the first one has 1. The second one has 2. But I can only say that they have 1 in common. So let's take 4xy and divide it out of the whole problem. So we're going to divide the front number by 4, take away an x and a y from each term in the problem. 12 divided by 4 is 3. I had x squared. When I divide an x out, I'm left with just x. The y's are the same and cancel out when I divide. Negative 8 divided by 4 is negative 2. The x's are both just x, which will cancel out. On the y's, I divided one out, so I'm left with 1 remaining. In my parentheses, nothing is left in common, which is good. And if I distributed this back, it would make my original problem. Okay, if you haven't tried it, I would pause the video and try number 12 just to check and make sure you're on the right track. Um, 28 and 21 can be divided by 7. If I look at their x's, the first has 5, the second only has 1, so they have 1 in common. If I look at the y's, the first one has 2, the second one has 7, so I can say they only have 2 in common. So let's take 7xy squared, and that's what we're going to divide out or factor out of the problem. So we're going to divide by 7. 28 divided by 7 is 4. There were 5 x's. I took 1 out, so it leaves x to the 4th. And the y squareds, I took y squared out, so y is gone. 21 divided by 7 is 3. The x's, they're the same. They're going to cancel out. I had 7 y's. I'm taking 2 out. So I will still have y to the 5th power. Final answer. Okay, y'all, I know this has been a longer video, but what you're going to do is now practice. So you can decide how you want to split that up throughout the week, but there are 2 different practice assignments. So they're both on Canvas. One of them is a quiz, like we've done in class. So not like a quiz, but a quiz is where you do the problem at your own pace, and then there's a meme that pops up and tells you if you're right or wrong. Please use your real name so that I know that you did it. The other practice is a worksheet, and that worksheet, trying to think out of the 2. Okay, that worksheet is one where you will complete the evens only, and then submit a picture through Canvas. The odds are already worked out. So if you wanted to try the odds, you could do that and then check your answer as you go and see if you got them right before you do the evens. Then later this week, at your own pace, there'll be another video and worksheet to practice as well. So I hope you're all doing well. Please email your teacher with questions if you have them, and I hope we can all be together again soon.